Okay folks, so today's video is a video on incomplete and complete combustion of hydrocarbons. And you might notice that I'm not filming this at home. So someone joked the other day about a 50 subscriber special, and I'm now on over 50 subscribers, at least until you all hit unfollow. Filming in school so I can do a couple of experiments and show you this stuff. Right. So incomplete and complete combustion of hydrocarbons. So as is our custom now, we're going to start with a quick quiz. So if you can pause the video and have a go at these questions. If you don't know these questions, it's likely that you haven't watched any of the previous videos, so it might be worth going back to tackle some of the previous stuff before diving into this. Okay, I'm going to start the video going in 3 seconds. 2, 1. So what is a hydrocarbon? It is a compound containing hydrogen and carbon only. Really important that you get that word only there. Carbon, hydrogen only. Alkanes saturated or unsaturated. Alkanes are saturated. Why are they saturated? Because they only contain single bonds. Single bonds. If there's any carbon-carbon double bonds, they're unsaturated. So alkanes are saturated because they only contain single bonds. How is crude oil separated into simpler mixtures? That is fractional distillation. And what is fuel oil used for? It is used for power stations and large ships, like container ships, that sort of thing. Right, so that's a quick quiz out of the way. So back to the title for today. So complete and incomplete combustion of hydrocarbons. Now, combustion is a fancy word that basically means burning. So complete combustion is when a hydrocarbon completely burns, and incomplete is when it doesn't fully burn. We'll go through that in a second. So, slightly cleaner on this side. As we said in the quick quiz, a hydrocarbon contains carbon, and it also contains hydrogen. So if we do the simplest example of that is CH4. You should be able to name that one. Have a go at naming it now. Give you 3 seconds. 2, 1. Okay, that is methane. Right, and if you are burning something, if you're doing combustion, it means you're reacting it with oxygen. And there's some pretty well-known compounds if you react carbon with oxygen and if you react hydrogen with oxygen. So what happens is, if you've got CH4, so you've got methane, we'll react it with oxygen, O2, and then the two products that we get are carbon dioxide, which is CO2. So the carbon reacts with oxygen to make carbon dioxide, and the hydrogen reacts with oxygen to make water, H2O. If we were going to do state symbols, methane is a gas, oxygen is a gas, carbon dioxide is a gas, and I know water is a liquid, but it's a liquid at room temperature. And you're talking that, this is actually being made in a fire. So like, this Bunsen burner is currently burning. This is the reaction that the Bunsen burner is doing. It's burning methane with oxygen. It's making carbon dioxide. And it's making water. And because of the temperature involved, the water is a gas when it's produced. We need to balance this equation. So a bit of practice at balancing it. Do you know what, if you want to pause the video now and have a go at balancing this equation. Okay, and I'm going to talk you through balancing it. So start with the carbons. 1 carbon, 1 carbon. So that's fine. Let's do the hydrogens next. 4 hydrogens over here, only 2 over here. So we need big 2. And then we look at over here, let's look at the oxygens. We've only got 2 oxygens on this side, and over here we've got 2 oxygens there and 2 lots of 1. So 2 there. 2 plus 2 is 4. So we need a big 2 there. So that one's balanced. So complete combustion of any hydrocarbon always produces carbon dioxide and water. And you've got to remember why do we do it? Well, most of them are used as fuels, right? So the 2 facts that you need to know about complete combustion of a hydrocarbon. So you need to be able to, actually I'll just add in the keyword here. You need to be able to describe complete combustion of a hydrocarbon, and the 2 ways that you describe it are carbon dioxide and water are produced, and then energy is given out, which means it's exothermic. Okay, so energy is given out. That's why we do it. We're burning them because they're a fuel, and it's producing carbon dioxide and water, which makes sense when you think about it. You've got to remember, hydrocarbons contain carbon and hydrogen only. So if you've got carbon and hydrogen, you're burning it with oxygen, so that's going to make CO2, and that's going to make H2O. Doesn't matter what the hydrocarbon is, it makes carbon dioxide and water. So, I mean, let's pick octane. Oct as in octopus, like 8. So it's C8H18. You don't need to know that. You don't need to be able to work that out, so don't panic over that. We're going to react it with oxygen. And what are we going to make? Well, it's complete combustion of a hydrocarbon. So we're going to make carbon dioxide, CO2, and water, H2O. And then we can balance that. We've got 8 carbons, so we've got to have 8 carbons there. We've got 18 over here, so we're going to need 9, because 9 times 2 is 18. And then let's look at the oxygens. We've got 8 lots of 2 oxygens, so that's 16. And 9 oxygens there, so 16 plus 9 is 25, which means we are going to need 12.5 lots of O2. You could double them all up, right? You could put a big 2 there, make that 25, make that 16, and make that 18, but it's just easier to have the 12.5. So complete combustion of any hydrocarbon makes carbon dioxide and water and produces energy. Next thing we need to look at is something called incomplete combustion. So incomplete combustion. I'm going to try and tilt the camera. My camera stand's not great, so I might have to move this in. So got a Bunsen burner here, and it's got an air hole on it. So if I open that air hole, I can't really see what I'm filming, so hopefully, so I open an air hole, this is complete combustion, right? Blue flame, letting loads of oxygen in, so it means every single bit of methane is fully reacting, fully combusting, because it's got enough oxygen. If I close that air hole, then it means there's not enough oxygen anymore. It means this flame isn't as hot. It's incomplete combustion. We are not providing it with enough oxygen to burn fully. So let's come back down to here. So for incomplete combustion, so if I've said I've got CH4, I'm going to react it with oxygen because we need some oxygen. And what am I going to make? Well, in an ideal world, I'm going to make carbon dioxide and water. And that is our complete combustion reaction. Let's just balance that quickly. 2 there and 2 there. Right. But if there wasn't enough oxygen here, if we didn't have enough oxygen to react with this, we have to make water, because if we don't give the oxygen to the hydrogen, you're never going to make hydrogen from this. Hydrogen's an explosive gas, right? You're never going to have any sort of combustion, any sort of fire producing hydrogen, because that would explode and react. So we haven't got enough oxygen here, So a shortage of oxygen. We can't rob it from the water, so we have to rob it from the carbon dioxide. So what happens is, instead of making carbon dioxide, CO2, that means we might make some carbon monoxide, which is just CO. You know, like, I don't know why I've started drawing this. Right, there we go. Here's Jeff. Say hi, Jeff. Right, Jeff has a monobrow. Right, sorry, Jeff. Okay, so there's Jeff with his monobrow. Mono means one. So monoxide, it's got one oxygen, right? So our carbon monoxide, by Jeff. Carbon monoxide's got one oxygen. Carbon dioxide's got two. So in incomplete combustion, you might make some carbon dioxide, you're going to make some carbon monoxide. If you've got even less oxygen, then you might make some carbon, which is like black soot, right? So carbon dioxide, carbon monoxide, or carbon. So complete combustion, when there's fully enough oxygen, the only thing you make is CO2. When you start starving it and there's not enough oxygen in there, you might make some CO2, you'll make some carbon monoxide and some carbon, which is soot. And carbon monoxide is really quite dangerous. So carbon monoxide is toxic, is the word you need to know. It's a toxic gas. And how it behaves as a toxic gas are, you breathe it in, and in your red blood cells, so I know this is going into like little biology now. So you've got your red blood cells, you know, your little biconcave disc thing, and you know they've got hemoglobin in them. And in your lungs, what normally happens is oxygen goes inside your red blood cells. That's not supposed to be a C, by the way. That's just supposed to be like your fancy red blood cell shape. Your oxygen goes into the red blood cell, and if you think your red blood cell like a red double-decker bus, right? And so it arrives in your lungs, fills up with oxygen as the passengers, and then goes on its merry way around your body, gradually dropping off all the oxygen passengers to all your cells. And then by the time it's lost all its oxygen, it's like the bus is empty of passengers, it goes back to your lungs, picks up a bunch of new oxygen. Now, if you're in an atmosphere that's got carbon monoxide in it, so incomplete combustion, so what happens is carbon monoxide gets into your red blood cell. It's like a passenger getting on the bus, right? So it's taking up a seat on the bus, and it never gets off because it bonds with that hemoglobin in your blood. And whereas oxygen gradually leaves, like passengers getting off the bus, getting dropped off around your body, carbon monoxide, once it's bonded with that hemoglobin, it doesn't leave the red blood cell. So it means there's less room in all of your red blood cells to carry oxygen to all of your cells. Remember, oxygen, very important for respiration. So eventually you get to a point where you get headachy, you feel really tired and lethargic, and it kills you. So it is toxic. It is colourless, so you cannot see it. It is odourless, so you can't smell it. And it's a toxic gas because it binds with your red blood cells and prevents them from carrying oxygen around your body. And so that's really dangerous, because then even if you leave the environment where there's carbon monoxide and go outside, I mean, that's great because you're not going to be breathing in any more carbon dioxide, but you don't get rid of that carbon monoxide that's already in your blood. So it's to do that, you need some sort of medical treatment. One possible thing is ultraviolet light, because then the ultraviolet light hits your blood and it breaks the bond between the red blood cell and the carbon monoxide, and it breaks that bond so it can leave. So essentially, carbon monoxide is toxic, prevents your red blood cells from carrying oxygen, because don't write this in an exam, but it is, this is like the passengers filling up the bus and they never leave. So in an exam, you'd put it prevents your red blood cells from carrying oxygen. Soot. So we just talked about carbon. So carbon, which is soot, so black sooty things. That's also dangerous. That can cause breathing problems, can cause things like asthma. It's also an issue. So in the Victorian times, you have chimney sweeps, right? So you have a chimney and it gets blocked with soot, and then you need to have your chimney sweep come and clean it out. That's a real issue because what the problems that the soot can cause. So you've got your beautiful fireplace here, yay, and then you've got your chimney. And then what normally happens is there's going to be, if you're ever seeing like a yellow flame, and in most fires, you know, it's like a yellow flame like that, that means it's incomplete combustion. So you've got some incomplete combustion happening, but all the gases are hot. So it takes oxygen from the room, and then all of the gases, so you've got carbon dioxide and maybe some carbon monoxide, are going up the chimney, which is fine because you don't end up breathing them in. But the issue is you're also making some carbon, which is soot. And then that carbon can end up, over time, gradually building up. That black soot stuff builds up and blocks the chimney, which means you get to a point where the carbon dioxide and, more importantly, the carbon monoxide cannot escape up the chimney, which means they end up going out into the room, which is dangerous. And lots of people die every year from carbon monoxide poisoning. Well worth investing about 10 or 12 quid in a carbon monoxide alarm. This is different from a smoke alarm, right? So it's a carbon monoxide alarm, and it just means that, you know, you might have, most of you will have gas boilers at home, boil your burn methane, provide you with heating at home, hot water, that sort of thing, and that's fine. But if there's ever an issue with the boiler and the flue gets blocked, which means the flue's like the chimney, which means carbon monoxide could be getting into your house. So it's like you have a little carbon monoxide detector which goes off. So that is complete and incomplete combustion of hydrocarbons. Why do we do it? Because it releases energy. Complete combustion makes carbon dioxide and water, and incomplete combustion might make some carbon dioxide, but will definitely make carbon monoxide and possibly carbon. Probably make all three. If you get asked on an exam, what are the products of incomplete combustion, I would stick with carbon monoxide, carbon, and don't forget it will also make some water as well.